Let us try to find out time response of second order system for stepping. So, as you know that depending upon the value of theta, the response magnitude is going to change. So, now we consider the case the theta value lies between 0 and 1. That means zeta value is greater than 0 and less than 1. We know that transfer function of a second order system is P of s by R of s is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. For unit stepping, R of s is equal to 1 by s. Then C of s is equal to 1 by omega n square by s into s square plus 2 beta omega ns plus omega n square. Here, the value of theta is lying between 0 and 1. The roots of the second order polynomial s square plus 2 zeta omega ns plus omega n square are complex and conjugate. So, to find out the time response, that means you know that the time response is nothing but inverse Laplace transform of E of s. So, to find out the time response, we need to convert the denominator polynomial into a standard factor. For that purpose, here I am writing C of s like this. C of s is equal to 1 by s minus s plus 2 zeta omega n divided by s square plus 2 zeta omega ns plus omega n square. So this is one of the standard form. No doubt about it. We need to convert this factor into another standard form. Now, this C of s can be written like this. 1 by s, you don't touch this factor. S by 2 zeta omega n s square plus 2 zeta omega ns. For this I am adding a term zeta square omega n square, and I am subtracting the same term zeta square omega n square plus omega n square. So that what happens? The value of the denominator polynomial is not going to change, but the denominator polynomial will change like this. Here, s square plus 2 zeta omega ns plus zeta square omega n square can be written as S plus beta omega n whole square plus 1 minus beta square into omega n square. This 1 minus beta square into omega n square, you know that this value we are calling it as damped natural frequency of oscillation. So 1 minus beta square into omega n square is equal to omega d square. So that C of S is equal to 1 by S minus S plus 2 beta omega n divided by S plus beta omega n whole square plus omega d square. This we need to convert into partial fractions. If you observe the denominator polynomial, it is having repeated poles. Okay, so using heaviside partial fraction expansion is S plus 2 beta omega n by S plus beta omega n square plus omega d square can be written as A1 by S plus beta omega n plus omega d square plus A2 by S plus beta omega n square plus omega d square. Here, applying the heaviside partial fraction expansion, we will get the value of A1 is equal to S plus beta omega n and A2 is equal to beta omega n. Or you can write the numerator polynomial as S plus 2 beta omega n divided by S plus beta omega n whole square plus omega d square. This can be written as S plus beta omega n by S plus beta omega n square plus omega d square plus beta omega n by S plus beta omega n square plus omega d square. Like this, you can write. So, the value of C of S is equal to 1 by S minus S plus beta omega n by S plus beta omega n whole square plus omega d square minus beta omega n by S plus beta omega n whole square plus omega d square. If you observe this factor, this is in the form of S plus A by S plus A whole square plus omega square. So, inverse Laplace transform of this factor is e power minus at cos omega t. So if you compare this value with this, here A is equal to zeta omega n and omega is equal to omega d. So if you apply inverse Laplace transform to this factor, you are going to get it as e power minus zeta omega n into cos omega dt. Coming to this factor, this is not there in the standard form. So you need to convert the second factor into standard form. For that purpose, you multiply this third factor with omega d and divide with omega d. So that P of s value changes as 1 by s minus s plus zeta omega n divided by s plus zeta omega n square whole square plus omega d square minus zeta omega n by omega d into omega d by s plus zeta omega n whole square plus omega d square. So this inverse Laplace transform, this is in the form of omega by s plus a square plus omega square. So inverse Laplace transform of this factor is equal to e power minus zeta omega n sin omega d. So now we can comfortably apply inverse Laplace transform to the equation. Apply inverse Laplace transform on both sides. You know that the inverse Laplace transform of C of s is C of t. C of t is equal to inverse Laplace transform of 1 by s is 1, which is u of t minus s by s plus zeta omega n by s plus zeta omega n whole square plus omega d whole square is equal to e power minus zeta omega n into t cos omega dt minus zeta omega n by omega d into e power minus zeta omega n into sin omega dt. So here if you observe, e power minus zeta omega n is common in these two. So 1 minus e power minus zeta omega n t, bring this out, cos omega dt plus 1 by zeta omega n by omega d into sin omega d. Zeta omega n by omega d value is equal to zeta omega n by square root of 1 minus zeta square into omega. This two will get cancelled. So you will get this value as zeta by square root of 1 minus zeta square. So P of t is equal to 1 minus e power minus zeta omega n t into cos omega dt plus zeta by square root of 1 minus zeta square into sine omega dt. In the denominator, you are having 1 minus zeta square. You take LCM, so that this is equal to e power minus zeta omega nt by square root of 1 minus zeta square into root of 1 minus zeta square cos omega dt plus zeta sine omega dt. So the relation between 1 minus zeta square, zeta and 1 is like this. If this is zeta, then this value may be 1 minus zeta square. Then this value will become 1. How will this will become 1? That we see. I am assuming that zeta and square root of 1 minus zeta square are the vertices of a triangle, so that AB is equal to theta, BC is equal to 1 minus zeta square. Using Pythagoras Theorem, I can write it as, I am trying to find the value AB square plus BC square. So, AB square plus BC square is equal to, AB is equal to zeta square plus 1 minus zeta square. BC value is equal to under root 1 minus zeta square. BC square is equal to under root 1 minus zeta square whole square is equal to 1 minus zeta square. Zeta square will get cancelled, equal to 1. It will become the hypotenuse of the triangle ABC. So here I can put an angle theta. This theta square root of 1 minus zeta square theta 1 A B C. So in triangle ABC, sin theta is equal to opposite side by hypotenuse. Opposite side is under root 1 minus zeta square, and cos theta is equal to zeta, where the value of theta is equal to tan inverse 1 minus zeta square by zeta. So we can write this C of t as 1 minus e power minus zeta omega nt by square root of 1 minus zeta square into sin theta cos omega dt plus cos theta sin omega dt. If you look at this trigonometric relation, sin A cos B plus cos A sin B is equal to sin A plus B. Therefore, P of t is equal to 1 minus e power minus zeta omega nt by square root of 1 minus zeta square into sin omega dt plus theta, where the value of theta is equal to tan inverse the value of theta is equal to tan inverse square root of 1 minus zeta square by theta. So this is called as time response of second order system per unit step input. If you observe, the C of t is consisting of two components. One component is having a constant magnitude. C of t is equal to 1 minus some constant e power minus beta omega nt into some amplitude A into sine omega dt plus theta. Okay, so if you observe this C of t value, it is composed of two components. A component whose value is constant with respect to time and a component whose magnitude is varying with respect to time. So this value is called the steady state component. And this value or this component is called the transient component. The transient component is the component whose value vanishes to zero as time t is tending to infinity. So if you draw the characteristic of this P of t with respect to time by taking time t on x-axis and P of t on y-axis, for depending upon the value of zeta, this value is going to change. For the time being, I am taking zeta value that is not equal to 0 and that is not equal to 1, so that the response of the system would be look like this. So that means the C of t is having damped oscillations. These are called the oscillations. That means the magnitude is oscillating between a peak value and a crest value, and the magnitude of the oscillations is decreasing with respect to time. So these oscillations are called as damped oscillations. So as the oscillations are damping out with respect to time, this response is called as known as underdamped response. Means as the theta value lies between 0 and 1, the step response of the system will have oscillations in it. And the oscillations will get damped out as t is tending to infinity. Okay, so that is the reason why this response is known as underdamped response. Suppose if theta is equal to 0, then the value of theta is equal to tan inverse square root of 1 minus theta square by theta. So this theta is equal to pi by 2. Then sine omega dt plus pi by 2 is equal to cos omega dt. So that the response C of t is equal to 1 minus e power minus 0 into omega n into t by square root of 1 minus zeta square into cos omega dt. C of t value is equal to 1 minus cos omega dt. So what is the value of omega dt? Is equal to square root of 1 minus zeta square into omega n. So as zeta is equal to 0, omega t is equal to omega n. That means C of t is equal to 1 minus cos omega n t. This is the response of the system where zeta value is equal to 0. So we see how this response would be as t is increasing from 0 to infinity. At t is equal to 0, cos omega nt value is equal to 1. So that P of t is equal to 0. So that it is a system that a cosine wave that starts at t is equal to 0 will have a peak amplitude of 2 and the system will have response like this. This is called oscillatory response. Means if zeta is equal to 0, we can say that there is no damping. So this response is called undamped oscillation or undamped response. And the frequency of oscillations is equal to omega n. So this omega n is known as the natural frequency of oscillation of the stem or undamped natural frequency. So I think you understood the value of omega n. In the earlier video, I told you that this omega n is known as undamped natural frequency of the system. Why it is called undamped natural frequency of the system? Because omega n is the value with which the oscillations in the system will get produced when zeta value is equal to 0. So this is what we call it as second order system response. If we combine these two, then what happens? As the zeta value is increasing from 0 to 1, the magnitude of these oscillations will decreases and the response will become undamped. Here I am drawing the C of t value. So the value of C of t for zeta is equal to 0 is like this. Zeta value is 0.5. The response may be like this. Then this is equal to 1. And if zeta value is greater than 1, this blue line is for zeta is equal to 0.5. Zeta value is 1. The response would be like this. If zeta value is further increased beyond 1, the response will like this. If zeta value is much more greater than 1. This I will show you with an example. I give the plots of this zeta varying from 0 to 1 in steps of 0.1 and 1 to 50 in steps of 10. I will give you the plots for the zeta and a single graph with the help of a simulation, so that I will explain how the response is going to change with respect to change in the value of zeta. Okay. So in the previous class, I explained you that zeta is greater than 1. ఇప్పుడు zeta value 0 కి 1 కి మధ్య ఉన్నప్పుడు ఎలా రెస్పాన్స్ వస్తుంది అని చెప్పాను. ఓకే, సో ఈ రెండింటిని ఇక్కడ మీకు ఎక్స్ప్లెయిన్ చేస్తాను. ఇప్పుడు నేను చెప్పిన ఈ డెరివేషన్ చాలా చాలా ఇంపార్టెంట్. మీకు నెక్స్ట్ నేను చెప్పబోయేది టైం రెస్పాన్స్ స్పెసిఫికేషన్స్, టైం డొమైన్ స్పెసిఫికేషన్స్ అని చెప్పి నెక్స్ట్ క్లాస్ లో చెప్తాను. ఓకే, టైం డొమైన్ స్పెసిఫికేషన్స్ డిరైవ్ చేయడానికి ఈ ఈక్వేషన్ చాలా ఉపయోగపడుతుంది. మనం డిరైవ్ చేసిన ఈక్వేషన్ ఏంటి అంటే దాన్ని ఎలా గుర్తుపెట్టుకోవాలి? C of t is equal to 1 minus e power minus zeta omega nt by square root of 1 minus zeta square into square root of 1 minus zeta square cos omega dt plus zeta into sin omega dt, where omega d is equal to square root of 1 minus zeta square into omega n. Like this, you can remember the equation. This equation is very important. Mathematical simplification.